In this short tutorial, we'll show you how easy it is to create a working application. We'll create and run the application, first with a virtual axis and then run it with a real single-board computer motion interface card abbreviated as SBC-MI card. First, create an empty project using the File New Project Empty menu. Let the parent directory of the new project be the project's directory of CoolMotion. Give it a name. A warning window has appeared, indicating that the project has not been compiled yet. Open the CMMain function block diagram using the File Open menu. Open the right panel to see the symbol of the CMMain function block. Select the SBC-MI card function block using the Add Library Element button and place it on the drawing. Place an MC power function block to turn the axis power on or off. Then place an MC read actual position block to monitor the actual position. Finally, add an MC move absolute to move the axis. Two additional logical AND gates are also required for the control logic. Create the desired connections. Function block pins can be connected by drawing nets. Default net names are generated automatically and can be displayed using labels. Function block pins can also be connected by net names. Let's connect a pin this way. Open the Connect to Net menu. Choose the desired pin and select a net name from the input pins list. A labeled net segment will be generated on the selected pin. Hold the Alt button and click on the net to show the connection. In the Connect to Net menu, you can also set a value directly for unconnected pins. Let's do it. Place input and output elements on the CMMain. These ports will serve as the interface to HMI and other applications. Check the application's inputs and outputs in the CMMain function block appearance window. Then connect them to the appropriate pins. Their name, data type and initial values are inherited from the connected pin. Rename the inputs with the same name in the Reference Name menu. Use the right mouse button to access the menu. Rename the outputs as well. Save your changes and build the project. Now compile the project using the build or rebuild command in the project menu. We need a virtual access to run our application. Use the Desktop Virtual Machine Create menu. Select the virtual machine's runtime platform. In this case, it's Windows PC. Give it a name. Add virtual machine components. In this example, there is only one SBC-MI card. Let's get started. The virtual SBC-MI card contains 6 axes. The virtual axes can be configured in the option menu. The visibility of the axes can be set. Only one axis is needed for our example. Let's launch the application. Bring up the Application Manager window from the taskbar. This window contains the application's currently measured time data such as step time, runtime, access time, process time. Let's launch the integrated minimal HMI from the desktop to test the application. The minimal HMI window automatically generates controls for all CMMain inputs and outputs. The Enable input enables the virtual SBC-MI card. The valid output indicates that this action is complete. Power on the axis. The background of the virtual axis changes from gray to white, indicating the enabled state. Let's start the motion with the Start button. The target position is set to 20 revolutions. When the axis has reached the target position, the done output will be true. Change the target position to 0, then start the motion by switching the Start button off then on. Turn off our application with the Power and Enable inputs, and close it with the Close All button on the desktop. The CoolMotion programming environment also includes a graphical debugger. This allows you to analyze your program while it is running. Let's see how to use it. Let's start the application again. The debugger can be started from the desktop. First, open the CMMain function block in the graphical viewer. Click the Enable button and let's see what happens in the viewer. The color of active function blocks and logical type wires with a value of true has changed to red. Let's place some labels to display the values of the wires or pins. The pin values of each function block can also be displayed in the debugger window. Let's see how. Select the function block in the tree view that contains the pin you want to display. Click on the pin in the Input/Output list, then move the selected pin to the Watch panel of the debugger. The values displayed here are updated cyclically. Let's do this with the other pins too. Toggle the power button and observe the value of the MC power status output changing. Place rising edge breakpoints on the execute input and done output of the MC move absolute function block. Let's open the breakpoint list window. After you start a motion with the start button, the program execution stops at the rising edge of the execute signal due to the breakpoint. The program execution can be stepped forward several times using the step button in the debugger window. Any number of steps can be set. Let's set 100. Click the Run button, and the program execution will continue to the next breakpoint. Return the axis to the 0 position through the breakpoints. Close the application with the Close All button on the desktop. We've seen how our application works in a virtual environment. Now let's move a real motor with a real SBC-MI card. First, connect the SBC-MI card to an unused Ethernet port on your computer. You can also use a USB Ethernet converter. Connect the motor controller to the SBC-MI card according to the specifications. Let's also provide power supplies. 5 volts is required for the SBC-MI controller. The 5 volts can also be supplied from a USB-C connection. In our example, 24 volts is required for the motor controller. Set the appropriate fixed IP address of the PC Internet adapter in the Network and Internet Windows menu. Some function blocks also have files containing configuration parameters, which are called property files. In the property file of the SBC-MI function block, you can switch between real or virtual access management. Let's switch from the virtual to the real environment. First, start the XML property editor from desktop, then click the Open button. The default property files are always created in the generated config directory during compilation. To edit a property file, you need to move it from the generated config folder to the project's config folder, otherwise it will be overwritten during compilation. In our example, the property file of the SBC-MI function block is named ax1, prop-link to .xml. Let's open it for editing. Select the global setting in tree view. Then set the device type from virtual to SBC-MI card. Here you can also change the step time of the trajectory generator and the IP address of the SBC-MI card. Select the Axis 1 in tree view. Here we can set the properties of the output of Axis 1. In our example, only the position unit needs to be set. The other settings can remain at the default value. Let's set the unit of the position to 1 revolution. For this, you need to set the number of steps per revolution, which is 3,200 in our case. Save the changes. We have already configured our application and our PC to work with the SBC-MI card. Finally, we need to configure the SBC-MI card for the motor drive. Let's start the SBC-MI controller configuration program of the desktop. The default IP address setting does not need to be changed in our case. Press the Read button to read the current settings. The current values should appear in the window, otherwise check the cable connection or the Ethernet communication settings. You can get more information about other settings by clicking the Help button, but we don't need to modify them for our example. Let's start the application now communicating with the real system. Let's also start the minimal HMI. The enable input starts the connection to the real SBC-MI card. The valid output indicates that it has been done. Power on the axis. Let's start the motion with the Start button. The target position is set to 20 revolutions. When the axis has reached the target position, the done output will be true. Change the target position to 0. Then start the motion. Switch the Start button off then on. Turn off our application with the power and enable inputs, and close it with the Close All button on the desktop. For more information, visit our website at link to freemotioncontrolsoftware.com.